Hello, TTI family! Did you know that building one of the world's biggest wind turbines starts with a strange paradox? The stronger and more reliable the wind, the harder it is to reach the perfect location. Nature really loves making engineers earn their paychecks. Mountain ridges, high plateaus, and exposed hills provide the steady airflow a massive 6.7 megawatt turbine needs to generate clean energy. But before those giant blades can spin, the crew has to conquer terrain that seems determined to say, "Not today." Long before electricity reaches the grid, roads must be carved into the mountains, steep slopes reinforced, and countless tons of equipment hauled through narrow, twisting paths. It's less like a construction project, and more like convincing a mountain to cooperate. This installation takes place near Zhangjiakou, deep within rugged mountain country. While the location is perfect for capturing powerful winds, every meter of road, every tight bend, and every crane movement demands careful planning. There are no shortcuts when your cargo weighs hundreds of tons and costs millions. That brings us to the true heavyweight of the operation, the mighty LG 1750 crawler crane. This isn't a machine you simply park wherever there's a little empty space. It requires a specially prepared platform, capable of supporting unbelievable loads from its tracks, counterweights, boom, and the enormous turbine components it will lift. If the ground settles even slightly during a critical lift, the entire operation could be at risk. To prevent that, the team builds a solid working pad using compacted aggregate, carefully leveled earth, proper drainage, and load-spreading plates wherever needed. It may not be the most glamorous part of the project, but without this foundation, nothing else could happen. Once everything is ready, the LG 1750 becomes the star of the show. But even the world's most powerful crane is only as good as the people operating it. Watching these professionals work is genuinely impressive. Operators, riggers, engineers, signalers, and ground crews communicate with remarkable precision, turning an incredibly dangerous job into what looks like a perfectly choreographed performance. It's engineering teamwork at its absolute best. The first major milestone is stacking the enormous steel tower sections. Each giant cylinder is fitted with precision-drilled flanges, so the pieces can be bolted together into one towering structure. Once connected, the tower is strong enough to withstand years of powerful winds, constant vibration, and enormous mechanical forces. With the tower complete, the challenge becomes even greater. Now it's time for the nacelle, the hub, and the gigantic blades. These aren't just heavy, they're expensive, highly engineered, and surprisingly sensitive to wind. Every lift happens slowly, often during a brief weather window when conditions are just right. Finally, the blades arrive on specialized transport trailers that somehow navigate winding mountain roads, despite carrying cargo longer than many aircraft. And here's where things get interesting. The installation doesn't follow the method most people expect. Instead of attaching each blade individually at the top, the crew has another impressive trick waiting, proving once again that building a giant wind turbine is anything but ordinary. Instead of attaching the blades one at a time, hundreds of feet in the air, the crew takes a much smarter approach. The entire rotor is assembled on the ground first. The hub rests securely on a specially designed support frame, while the three gigantic blades are bolted on horizontally. It may look like someone is building the world's biggest ceiling fan, but this method is far safer and far more efficient. Working at ground level gives technicians easier access to every connection, stable platforms to stand on, and a much safer environment than balancing high above the mountains. Watching these skilled workers move confidently around components worth millions is a reminder that experience is just as valuable as expensive machinery. Once all three blades are attached, the rotor transforms into one enormous three-bladed masterpiece. And now comes one of the most nerve-wracking moments of the entire project: the lift. At first, lifting the rotor might sound simple. Hook it to the crane and send it skyward, right? If only engineering were that easy. This giant assembly is anything but balanced. Three incredibly long blades stretch out from the hub, creating a load that's constantly trying to shift, twist, and catch the wind like a giant pinwheel with its own opinions. Even a gentle breeze pushing harder on one blade than the others can make the entire rotor rotate unexpectedly. Instead of moving straight upward, it can swing like a pendulum, or twist in ways that place enormous stress on the lifting equipment. That's exactly why every movement is carefully calculated, long before the crane ever leaves the ground. To keep everything under control, the crew uses guide ropes, auxiliary cranes, specialized rigging, and a bright yellow lifting beam. This clever piece of equipment spreads the lifting forces across several attachment points, instead of concentrating all the weight in one area. The result is a more balanced lift, less stress on the blades, and much greater control throughout the operation. Before the lift begins, the team performs what feels like one final rehearsal. Every sling is inspected, temporary supports are removed, clearances are checked, and the danger zone is cleared. It's a powerful example of professional teamwork, where every person understands that safety comes before speed. Once the massive rotor is finally secured to the nacelle, it officially becomes the turbine's beating heart. Those giant blades are no longer oversized cargo. They're now precision-built wings that will convert moving air into clean electricity. Thanks to the pitch system inside the hub, each blade can rotate slightly on its own axis, allowing the turbine to capture wind efficiently while protecting itself during powerful gusts. From a distance, the project now looks complete. The towering structure proudly dominates the mountain skyline, ready to harness nature's power. But the crew isn't finished yet. The giant LG 1750 crawler crane that made these incredible lifts possible must now be dismantled piece by piece with the same patience and precision used to assemble it. Even taking apart the crane is a major engineering project. Assisted by a smaller SANY crawler crane, the team carefully reverses weeks of setup, proving once again that true heavy lift professionals make even the toughest jobs look almost effortless. Ironically, the biggest crane on site can't completely dismantle itself. It needs a helping hand. That's where the smaller Sany crawler crane steps in, lifting boom sections, lowering heavy components, and handling awkward pieces that are definitely too big for a few determined workers and a good luck attitude. The dismantling follows a carefully planned reverse sequence. First, the crew removes unnecessary rigging, then lowers the massive boom, disconnects its sections, and finally removes the enormous counterweights before preparing everything for transport. Every step is carried out with the same precision used during assembly, proving that these professionals never cut corners. This final phase also reminds us that every completed wind turbine is supported by an incredible amount of temporary engineering hidden behind the scenes. Before leaving, the team performs one last inspection, making sure all temporary lifting equipment has been removed and everything is secure. With the work complete, the giant turbine proudly overlooks the mountains, ready to transform powerful winds into clean energy. The crew packs up, leaving behind not just a remarkable machine, but another impressive example of engineering skill, teamwork, and determination.